we can convert a practical voltage source to a practical current source and vice versa. The conversion is simple. Let's say Vs and Rs of this practical voltage source are given. Next, we draw the practical current source model. Is can be calculated by using Ohm's law. Vs over Rs is equal to Is. The internal resistance Rs remains the same. To convert a practical current source to a practical voltage source, we also use Ohm's law to find Vs, and for both sources, the same internal resistance Rs is used. Example 2. Show that the load current calculated from its voltage source is the same as the one in its equivalent current source. In this voltage source model, the load current can be calculated by applying Ohm's law. The voltage source, 10 volt, divided by the total resistance, 1200 ohms, is equal to 8.33 mA. This is the load current. Now we convert this voltage source to a current source. The same internal resistance are used, 200 ohms. For voltage source, we put it in series. For current source, we put it in parallel. Then, the current source Is here can be calculated by using Ohm's law, using 10 volts divided by 200 ohms, this calculation here, equal to 50 mA. The load current can be calculated by current divider rule, as this, and as expected, the same value, 8.33 mA, is calculated. Same. Example 3. Transform voltage source to its equivalent current source. This is the voltage source. Later on, we transform it to this current source. And determine its voltage at node A. Node A is here. And the branches current, this 3, 1, 2, 3. To convert the practical voltage source to a practical current source, we use the same internal resistance, 200 ohms. 200 ohms. To find this constant current Is, we use Ohm's law. 30 volts divided by 200 ohms is equal to 0.15 ampere. To find the voltage at node A, we first find the total resistance of these 3 resistors. These are the steps. To find the voltage at node A, we can apply Ohm's law, use the total current times the total resistance. Is times RT work out to be 20.54 volts. To find the current going through Rs, we can apply Ohm's law also. Voltage at node A is in fact the voltage across Rs. So current in Rs is equal to VA divided by Rs. So we can find the current to be 103 mA. Similarly, we can find IR1 and IR2. In this example, a practical current source is given. We are required to convert it to a practical voltage source. Then we are going to calculate some current and voltage value of this converter circuit. To find this circuit current, we first find the total resistance of this 3 resistor, which is the sum of this 3 value equal to 2.38 kilo ohms. Then use 15 volts divided by this total resistance, we get the circuit current to be 6.3 mA. Use Ohm's law, this circuit current times the individual resistance, we can find out the voltage drop across each of these 3 resistors. All these are the answers. In this video, you have learned quite a few points. An ideal current source has infinite internal resistance. An ideal current source is able to provide an output current with a constant amplitude regardless of the load variation. However, a practical current source does not have an infinite internal resistance, but just a high internal resistance normally. Because of this internal resistance, the amplitude of the output current changes with load variation. Current sources can be connected in parallel. A practical current source can be converted to its equivalent voltage source and vice versa. A pair of equivalent sources have the same internal resistance. Voltage source, current source, and internal resistance obey Ohm's law. Next is Part C, Superposition Theorem in Circuit Analysis.